They should be up. It should be on under Wednesday. I don't know if you remember this yesterday, but the first thing I had you guys do was I asked for the degree of the polynomial, right? So that's what the fundamental theorem of algebra is related to. So it says this. A polynomial of degree n has exactly n, oh, you can't see it, has exactly n zeros or roots, using that term interchangeably. Okay, now but here's the key thing. Some may be repeated. And some may be non-real. Do you guys remember the word I gave for the kind of numbers that were all of the numbers, the real and the non-real? It started with a C? No? Complex? Okay. So when I'm saying a polynomial of degree n has exactly n zeros or roots, these are complex numbers. Okay. So complex numbers covers real and non-real together. How are we going to see the real ones? They're on the graph. How are we going to find the non-real ones? I'll talk about that later. Okay, so do you remember a minute ago you were asking me, Logan, about why on that worksheet the repeateds were listed? Because today that becomes important, because if I had a total of the degree and I know that it's a multiplicity of 2, that counts for like 2 of the roots. Or if it was a multiplicity of 3, it counts for 3 of them. Okay, so those multiple roots, we count each one as a 0 or a root. Okay, so what we're going to do today then is we're going to very much rely on Decimus or our graphing calculator to find real ones, and then we're going to rely on our algebra methods to find the others. Okay, so this is one big example. So before we start, let's look up at the top. And would you circle the degree of the polynomial? Okay, so the degree of the polynomial, would you write it in the blank at the bottom of the page? So no matter what, the answers to this blank and the next blank are going to be the same. So if I know the degree of the polynomial, that means the number of complex roots is going to match that. I'm going to just write a little note about how we're going to do this. So far, have I used a calculator at all? No. I haven't looked at the graph. The next part you're going to want to look at your calculator or Decimus for, because the number of real roots you need to look at the graph for. And this is going to tell us, we're going to just look at how many x-intercepts there are. Okay, so I'm going to pull up my, yeah, you can look at Decimus if you want, because I want to be able to see my notes in my screen. I'm going to pull this onto my graphing calculator. I think I already typed it in. Oh, I didn't because I've moved it around, but and right now I don't need a super, okay. So what's the answer to that question? I don't need to know the exact ones yet. How many x-intercepts does it have? 2. That is the number of real roots. Okay, so now how am I going to find the imaginary? Imaginary means the things with the eyes in it. We've dealt with that before. We'll talk about it again. Well, it's not, you can't see them, but you work backwards. If there were 4 total and 2 are real, what does that leave to be imaginary? 2. Okay, so does that make sense? All right, now, depending on what I ask you to do here, I think we all could generate a list of potential zeros, right? All right, so on our list would be plus or minus 1 and plus or minus 2 and plus or minus 4 all over 1. Agreed? Okay. Looking at my graph, which ones are actually the zeros on the graph? Can you see that? 2 and negative 2. Does anyone have Decimus up? It's probably a little bit closer on there, but can you see it's 2 and negative 2? Okay. Depending on what I ask you to do, don't guess. If you're not sure, you should plug them in and check. Like, what do I mean by plug them in and check? I mean this. If you plug 2 in and you raise it to the 4th, so blurry. Why? There we go. And then we did minus 3, no, not that, not that. Minus 3 times 2 to the second. Okay, so like if you're unsure, you can plug them in and guess. Do you see how it gives me a 0? Okay, but we're pretty sure looking at the graph that was a pretty exact one. So the real zeros are 2 and negative 2. All right, are you ready to find the imaginaries? Who likes synthetic division? I do. That's how we're going to find them. So this is like why I was saying I like this lesson, because it kind of pulls together all the things we've learned before. We're going to divide off our real zeros, and we're going to be left with something that's going to give us imaginary solutions. All right, don't forget, there's an x to the 4th, but there is no x cubed. So remember what we're going to put in that spot? 0. Good. So I'm going to start with, I'll do the 2 first, put it in the box. And then I have a 1, I have a 0x cubed, I have a negative 3x squared. Oh, do you see there's no x term? So I'm going to do a 0 again, and a negative 4. All right. We have a 1 down there. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Some of you are done already. 2 is 2. Okay, phew. Did you get a remainder of 0? All right. Now, I don't know if you remember this from your quiz the other day, but if you wanted to divide off now the negative 2, don't go back to the original. Now we're going to take this and divide off negative 2. So let's put negative 2 in the box. And I have 1, 2, 1, 2. Drop that down. Negative 2 times 1 is negative 2. 2 plus negative 2 is 0. That's okay. We keep going. Negative 2 times 0 is 0. 1 plus 0 is 1. Negative 2 times 1 is negative 2. Okay. Now, what polynomial is this? Hint, we started with a degree 4 and we divided off x twice. This is x squared plus 1. Okay. So to find the imaginary zeros, what I do is I set it equal to 0 and I solve. We did this about a month ago. Let's move the 1 to the other side. We solved things like this. We took the square root, we added a plus or minus, and what did we have to add also into that expression? What's the square root of a negative? There has to be an I. All right, I have my 4 roots, okay? 2, negative 2 are the real ones. There's also 2 non-real. So my imaginary roots are imaginary or non-real is fine. R plus or minus I. Okay. So let's summarize. What's the value of the x-intercepts? Which ones were x-intercepts? 2 and negative 2. Those are the real ones. When I ask for all of the roots, then you'd list 2, negative 2, 1i, negative 1i. Okay. Whew. How are you feeling about that?